Everyone, as today, as in the last video, we have discussed about atomic structure, J.J. Thomson Plum's coding model. Here we are going to study Rutherford alpha scattering experiment. So first of all, here I'm gonna just draw a bit diagram of that. Yeah, here was the lead box, lead box, and in that lead box what was sprayed in the lead box they placed the polonium or radium radioactive material. Polonium or radium, those were what? Those were radioactive material, radioactive particles or material. After that, here they put that sheet of, we can say this was alpha scattering sheet, and they placed the gold foil over here, gold foil. Okay, so when from this they pass the what? They pass the when from this they pass the lines, means rays. So some rays deflected, while some pass through that. Okay, non-deflected particles some pass through that. So this was basically done in helium, helium alpha particle, which is helium atom. Okay, alpha particle is helium atom. So from this experiment, what they observed that nearly 99.9 alpha particles pass undeflected. Means nine here they pass 100,000 uh, rays, and from those 99.9% rays was what? The rays undeflected. Undeflected means they do not deflect from gold foil, they just pass through that. Okay, undeflected. Here you can see these are undeflected. Undeflected. Some of the alpha particles were deflected by small angle. कुछ इनमें से अल्फा पार्टिकल जो डिफ्लेक्ट हुए वो छोटे एंगल से डिफ्लेक्ट हुए. Some of alpha particles deflected by small angle, छोटे एंगल से डिफ्लेक्ट हो गए. While very few, कुछ very few means 20,000 alpha particle return back. Alpha particles return back. मतलब वेरी फ्यू, बहुत ही कम, 20,000 में एक ही, सिर्फ एक या दो तीन जो कि रिफ्लेक्ट बैक हो गई, गोल फाइव से टकरा कर रिफ्लेक्ट क्या हो गई? बैक हो गई. ओके, आफ्टर दैट from and they deflected the large angle, and that was 180. From this experiment, the conclusion of Rutherford atomic model was what he concluded. So here the conclusion from this experiment, they got what? Yep. They got most part of atom is hollow, or uh, we can say empty. Most part of atom is hollow. तकरीबन जो एटम का पार्ट था वो क्या था? होलो था, और कैसे एम्प्टी था, बिकॉज these rays passes through that, तो कोई वो फर्क नहीं आया. So this was the most atomic part was empty. Another was what? The positive charge reside in very small space. पॉजिटिव चार्ज एक पॉजिटिव चार्ज पड़ा हुआ था, वेयर? इन वेरी स्मॉल स्पेस इन न्यूक्लियस. न्यूक्लियस के अंदर एक छोटा सा small space पर एक positive charge पड़ा हुआ था, so that these some rays these deflected. इनकी वजह से कुछ rays क्या हो गई, deflected हो गई. After that, third was what? Um, the positive charge is heavy or said that there is something which is very heavy in atom. इनको लगा कि ये जो positive charge है that is heavy. Positive charge is present and other thing is present that is heavy. Something is also present that is heavy. कुछ ऐसा पड़ा हुआ है जो heavy है, बहुत भारी है. On that time they were not known about that neutron is also present in the nucleus, but they thought कि कुछ है जो कि heavy है. Okay, so after that they also told that number of electrons is equal to number of protons. जितने प्रोटॉन के नंबर होंगे उतने ही क्या है, न्यूट्रॉन के नंबर और इलेक्ट्रॉन के नंबर्स होते हैं. ओके. Another thing it says the size of nucleus is very small as compared to size of atom. Nucleus का size बहुत ही छोटा है अगर हम compare करें size of atom से. Size of nucleus is very small as compared to size of atom. What is the size of nucleus? Size of nucleus is 10 to the power minus 15. Size of atom is 10 to the power minus 10. So the between them difference was about 10 to the power minus 10 to the power 5. This was the difference, means 100,000 difference between the size of the nucleus and size of the atom. So after this, in the Rutherford, he also told that electron revolve in circular orbit around the nucleus. के electron circular orbit के अंदर revolve करता है nucleus के around. Electron revolve in circular orbit. Circular orbit around the nucleus. Nucleus के around electron क्या करता है, revolve करता है in the circular orbits. So he told that here, for suppose here I have for suppose here I have what? Here I have an atom which have what, electron which is revolving, and through this here we have centripetal force. Okay, centripetal force. So in here we have positive charge, and between positive and electron there is what, force of attraction, that is known as electrostatic force. That is called as electrostatic force or force of attraction. He told that electrostatic force is equal to centripetal force. जितनी यहाँ पे centripetal force लग रही है उतनी यहाँ पे electrostatic force लग रही है. Okay, and so here as Rutherford told the whole model. Now what is we can say drawbacks or fail which Rutherford model did? Drawbacks or fails? Okay, so what he did, yep, he basically, as Maxwell theory said that when any accelerated particle will emit radiation and lose energy. कोई भी अगर particle क्या कर रहा है, accelerate हो रहा है, means उसकी velocity change हो रही है, that particle will emit radiations and lose energy. However, Rutherford did not tell that electron is revolving and it will lose energy by losing its Maxwell theory. He said when any accelerated body, कोई भी अगर body accelerate हो रही है, any accelerated body will emit radiations and lose energy. Lose energy. कोई भी मैक्सवेल ने बताया था कोई भी एसिडेटेड बॉडी है जो कि क्या करती है रेडिएशंस को एमिट करती है और एनर्जी को क्या करती है लूज करती है. हाउएवर जब हमें रदरफोर्ड ने बताया था वो रदरफोर्ड टोल्ड अस कि ये एक इलेक्ट्रॉन ये एक एटम है इसके अंदर ये इलेक्ट्रॉन है ये पॉजिटिव चार्ज है इलेक्ट्रॉन रिवॉल्व करेगा मीन्स इलेक्ट्रॉन इज चेंजिंग इट्स वेलोसिटी और मैक्सवेल के हिसाब से जब ये इलेक्ट्रॉन एसेलेरेट हो रहा है इट विल अपनी वेलोसिटी को क्या कर रहा है चेंज कर रहा है. सो इट विल लूज रेडिएशन को क्या करेगा एमिट करेगा और एनर्जी को क्या करेगा लूज करेगा. तो ये इलेक्ट्रॉन जब अपनी एनर्जी को लूज करेगा रेडिएशंस को एमिट करेगा एनर्जी लॉस करेगा तो मीन्स ये आकर पॉजिटिव की चार्ज के अंदर गिर जाएगा न्यूक्लियस के अंदर. सो दिस वाज द ड्रॉबैक ऑफ रदरफोर्ड व्हिच इट कैन नॉट एक्सप्लेन प्रॉपर्ली. आफ्टर दैट ही कैन नॉट एक्सप्लेन द स्टेबिलिटी क्योंकि एटम अभी स्टेबल ही नहीं है हियर सो ही कुड नॉट एक्सप्लेन द स्टेबिलिटी of an atom. Cannot explain. Okay. And one more thing, he can't explain line spectrum or discrete spectrum. इसने can't explain line spectrum or discrete spectrum. इसने ना ही हमें line spectrum और discrete spectrum दोनों नहीं बताए थे. Okay, so this was all about Rutherford and some failures of Rutherford and atomic model of Rutherford. After that, to do this correction, there was the Bohr atomic model who did the correction of this stability of an atom, which we're gonna discuss in the next video. Hopefully, you like this video. Share with your friends, families. Bye bye.